class we have discussed something about vectors and scalars, vectors and scalars. This today we'll discuss more about this. As you know, these physical quantities, we are more concerned with the measurement of the physical quantities, So, this can be done by doing certain mathematical operations on these physical quantities, that is vectors and scalars. Before going to the mathematical operation performed on these specific physical quantities, vectors and scalars, first we will be acquainted with the physical quantities. Previously, I have explained the definitions of vectors and scalars. I have also given the specific examples on this type of quantities. In case of scalars, it can be represented by any letter, maybe a small letter or a big letter. Suppose mass is represented by m mass. Suppose length is represented by L. Similarly, time represented by T. So these quantities, scalar quantities, can be represented by a small letter. We will represent this by its magnitude only. Suppose you consider a case, in case of mass, suppose this mass is 5 kg. So for m is equal to 5 kg. m1 is equal to 5 gram. We cannot write m is equal to m1, is not equal to m1. M is not equal to m1. Why? Because the numerical part is equal. Although the numerical part is equal, the unit part is separate, different. So the two figures, the two quantities of a specific physical quantity will be equal if the magnitude are same, means the numerical in the magnitude part is same, also the unit part is same. But in case of vectors, suppose you represent a vector, the vector can be represented by single letter. Suppose A, like this, arrowhead over it, and this is another vector B. We can equate A is equal to B. Two vectors are equal if and only if your magnitude of A is equal to magnitude of B and the direction is same. So two vectors are same if their magnitude are same and direction are same. So two vectors are said to be equal vector if their magnitude are same and the direction are the same. Similarly, negative vector. Suppose this is a vector, suppose this is a vector P, So what is the negative vector of P? The negative vector of P can be drawn like this. Negative vector, that is minus P. This is P and this is minus P. So P, negative vector P is equal to minus P. Only magnitude remains constant. Magnitude remains constant, only direction changes. So the negative vector of a vector is nothing but the magnitude remains same but direction is reversed. So this is the negative vector. Then another type of vector you can represent, suppose this is a vector A. This is a vector A, suppose say A. This A vector is nothing but, if we divide it by A vector by magnitude of this A, magnitude A, this becomes a unit vector along the direction of A, that is A cap. So A cap is a unit vector along the direction of A whose magnitude is 1. Suppose you can write the magnitude of A cap is 1. Magnitude of A cap is 1. Similarly, this is the unit vector. Similarly, null vector. What is a null vector? Null vector. Null vector can be represented by 0 cap. 0 cap. 0 cap. That is any vector. What is null vector? Any vector. Any vector having an arbitrary direction, arbitrary direction, and with a magnitude magnitude as 0. So the magnitude of null vector is 0. Magnitude of null vector is 0. Then we will come to your mathematical operations on mathematical operation scalars and vectors. Mathematical operation on scalars and vectors. Take for example a scalar. Suppose your 10 kg. If you add it with 4 kg of a particular physical quantity, let's say mass, it becomes 14 kg. Similarly, 10 kg, you can write, subtract it 4 kg, this becomes 6 kg. We can, if we multiply 5 meter with 5 meter, this becomes 25 meters square. If we divide 5 meter divided by 5 meter, it becomes 1 by 40. It means we mathematical operation done by using the arithmetic rules of the arithmetic in case of scalars. But in case of vectors, you can never do the operation in such a way. In vectors, in case of vectors, in case of vectors, in case of vectors, the operations, mathematical operations, mathematical operation done rather geometrically. Geometry. So when we make addition of two or more vectors or subtraction of two or more vectors from each other, then we do proceed geometrically. So there are two methods for vector addition. That is your graphical method. Geometrically you do in two ways, one graphically, secondly analytically. We perform addition of two or more vectors in geometrical, in graphical, method. Second process is your analytical method. You can do it graphical method or analytical method. Analytical method. Before going to the vector addition or subtraction, we will be acquainted with two important rules using which we can perform vector addition and or subtraction. First thing is our law of triangle. Two laws. You use law of triangle. Then law of parallelogram. First, describe what is law of triangle. If the two vectors are represented by two sides of a triangle taken in order, then the third side will represent the resultant vector taken in opposite order. I can explain like this graphically. Suppose this is a vector A, this vector A, and this is B. This is the vector B. So we can draw, this is the tail of the vector, this is the head of the vector. We draw from the head of A, we draw B from head of A, keeping the direction same. So this is B. Then if we join the tail of A to head of B, it will represent the resultant R. So A plus your B, this becomes the vector R. In graphical method, if you draw a specific vector keeping the scale in proper manner, then if you draw this, then draw this, then joining this to this, by measuring with scale, we can find out what is the magnitude of this, actual magnitude of this vector, and measuring this angle, we can say the resultant is making some angle alpha to A. Similarly, we can explain the law of parallelogram. Law of parallelogram. The law of parallelogram, if two vectors are represented by two adjacent sides of a parallelogram, then parallelogram, then the resultant of suppose two vectors can be represented, will be represented by its diagonal passing through the common point and away from it, So this is the law of parallelogram. So how can he explain it graphically? Suppose this is a vector A and this is a vector B. If we draw a parallelogram using those two vectors, we take a parallelogram like this. So this is a parallelogram passing to the common point. Suppose this is O P U S. So the resultant of those vectors A and B is O Q. This angle is your theta. Suppose this angle is alpha. So we can write here OP plus OS is equal to OQ. This vector is your R. Suppose say this A vector, we write A plus B is equal to R. If the vectors are given to us, we can draw graphically the vectors and form a parallelogram. Draw a parallelogram by measuring the diagonal of the parallelogram. You can find the length of the diagonal, which will represent the magnitude of the resultant, and we can measure this angle theta, which is given initially, and we can measure alpha. This will give the direction of the resultant alpha. So this is all about vector addition by using graphical method. In next class, we will discuss the addition substitution using analytical method. Okay, bye.